Welcome to this video on artificial intelligence tool. On the CISSP exam, you are expected to understand machine learning and artificial intelligence based tools. Now, machine learning is just a subtopic of artificial intelligence. So, let's focus on AI first. Now, AI is basically just software capability that going to analyze the system environment and then make independent decision. That's really the whole focus of AI. Now this video could be a course in and of itself. There is a lot of information to discuss. There is a lot of things happening in this world of AI. However, for the CISSP exam, you mainly just need to understand the current and future role that AI will play in information and cybersecurity. The overall goal of AI is just to reduce the workload. So it's to reduce the workload of human being and minimize errors that are caused by stress, fatigue and so on. Now within AI, there are three specific levels that you need to know. The first thing, narrow AI or weak AI. This is also called artificial narrow intelligence. So this is weak or narrow. The idea is that we are focused on a single task without any human interaction. So meaning anything learned or gained from a performing a task will not automatically be applied to any other AI related task. It's just one task. A very simple example is Siri by Apple or Cortana by Microsoft or Alexa by Amazon. Hey Alexa, play a song, and then all of a sudden the song will start playing. But that's it. It's not going to play any other song. It's just going to play the song I am saying to play. Now, this is an example of narrow AI. So, other place you might see these are code bots, such as help topic bot, help desk bot. These are on the website, customer service type bot, automatic enrollment process, those kind of things. Those would be example of narrow AI as well. Next, we have artificial intelligence or AGI. This is focused on mimicking human behavior by completing complex tasking. This is also called full or strong AI. So basically, in the simplest term, this is where artificial intelligence and human beings are equal or close to equal at intelligence level. So you can complete a lot of complex tasking with this specific type of artificial intelligence. Then we have artificial super intelligence or ASI. This is also called super AI. Super AI is when the AI itself will surpass human intelligence level. So a computer will exceed the ability of human intelligence. This is the future of artificial intelligence. We are not quite there yet, but at some point the scientific community expect to get there. So within cybersecurity or information security, what can you expect to see from an AI perspective? Really, the most of it's going to come from the narrow intelligence. That's what we are going to see in the most within some of the tools. For example, expert system, these are computer programs that are designed to mimic human behavior. So this is a form of general AI, but it can also be within narrow AI as well. And then there's also natural language process or NLP. This provides computer the ability to understand and respond with text and voice. So you will see this in narrow AI and some form of general AI. A good example, hey Alexa, play this song. Boom. And that's understand your ability when you are talking to a sensor. The sensor picking it up, processing your voice, turning into text, and then eventually into commands that it is going to send to the computer. So that's a good example of how that works. There's also thing like virtual assistant, chatbots. Also email spam protection can be implemented using AI as well. And that would be in the form of narrow AI or weak AI. Now that takes us into machine learning, and this is really where you are probably going to see the most questions. AI is just kind of border topic where machine learning is kind of focus for information security and cybersecurity side. So machine learning allows software to learn data patterns and also relationship as well. And machine learning can help improve automation capabilities by predicting data values and also patterns. So we can use this machine learning as a behavior based detection system in cybersecurity. It can help automate threat detection. AI can also be used as a first line of defense for security analysts to evaluate potential threats and maybe even identify advanced persistent threat as well. So there is a lot of advantage for security industry in this regard. Now machine learning has to be taught. It will create its own baseline by observing and looking for anomalies, but it needs to feedback from us, and that's where supervised machine learning comes in. Supervised learning will use labels to train the computer on what to look for. So if you recall all the way back to domain 2, where we are talking about how we are handling data, marking and labeling, this is bringing this right into play. We have to label the data so that the machine can learn more about the dataset, and it will increase the accuracy in its decision making. So within supervised machine learning, it's really what we are doing is training. We are training the computer to data mine. We are going to data mine, and then we are going to give the computer feedback based on the result that it is providing. So companies like Google, YouTube, Facebook and so on, a lot of companies like this use this technology. And so as you tell the computer algorithm what post you like, what videos you like or dislike and so on, the computer will recommend similar or contrasting option for you to continue using the website. So it enhances user experience. The same could be applied within cybersecurity, where instead we are looking for common patterns of threats and attacks versus what post or what video we would like to see. Now the one drawback here is called machine learning bias, because we are interacting and we are building the data set, the data model. There's going to be bias in how the machine is deciding what to present to us. So what's going to end up happening is the machine data model is going to be built on our feedback, and then that bias toward the dataset is going to be presented, meaning we might be missing some other important data points that are part of the data mining operation. So there is a large dataset out there, and if we only click the certain things, that's the only feedback we are going to get from the machine learning algorithm. So that's when we might want to use unsupervised machine learning, where it uses unlabeled data to training the computer what to look for. So what it is going to do is analyze unlabeled or unstructured data groups, also called clusters, to detect possible or potential data patterns. So clustering is a data mining technique as well, but this is where all of the data is unmanaged and we are looking through all of it for patterns, similarities, differences and so on. This is often used in big data, advertising, recommendation or search engine, medical analysis. A lot of other areas use this type of technology. What we are looking for is hidden pattern of information, and maybe there is an advanced persistent threat or some kind of attack that has a certain signature, and we might have missed that using supervised machine learning. Well, with the unsupervised, it has the ability to basically mine through all of the data and then start looking for patterns. So it might be able to detect those patterns and help us identify those unknown threats or otherwise unknown security risk. And of course, like anything else, we are not locked into doing one way or the other. We can use semi-supervised learning method as well, which combines both the supervised and unsupervised machine learning. So maybe a certain set of data, like sensitive data, we use supervised machine learning, whereas everything else we use unsupervised. So now we can detect attack and threats while we are analyzing a specific dataset, looking for very specific things. So there's a variety of way we can do this. Then there is a different kind of machine learning called reinforcement. Now the reinforcement is very similar to gamification, where the reinforcement learning will use both positive and negative feedback in order to determine the next potential behavior pattern. So what ends up happening is there are agents that are used to collect information from their environment, and they determine positive and negative result. And then what it ends up doing is it start making decision by rewarding itself with a positive outcome and then punish itself with negative outcome. So it is form of gamification, if you will. So, and where you will see this kind of machine learning is advertising, search engine, stock trading and more. But a really good example is Tesla. Tesla has an electric car that is designed to drive itself. It uses reinforcement machine learning to drive itself. So as the car is driving itself, it is making millions of decisions based on all the inputs from the agent that are installed on the car. Sensor like speed, distance from the next car, or the line over battery levels, and all those different things. An agent will reward themselves if the driver is not providing inputs. So if the driver is not grabbing the wheels or stepping on the brake or accelerating or anything like that, the car believes that it is doing the right thing. So it will continue to do the same thing over and over and then start talking in more information. But if the driver has to make an adjustment, that's considered negative reinforcement. Hey, the car is not doing its job. So as the driver interacts with the car, the agent will negatively reinforce themselves and make new calculation to avoid making those decisions in future. So this is very good example of how machine learning can help us. There's also something called artificial neural network. This is deep learning algorithm to make independent decision based on whatever the data set is or whatever those data inputs are. It is used for email spam detection, business intelligence, natural language processing and more. There is a ton of different way that we can do this. So just simple example of how this would work. Here's an example from ibn.com where you have the input layer here and these are all the different inputs, and then what ends up happening is within this neural network, this is unseen to the user and user has no idea what's going on. This is all the artificial intelligence going on behind the scene, and you can see how all these different inputs are being compared to all these different data points. It's being analyzed across the board and then decisions are made. So this is the result of the output. So you have multiple inputs with limited outputs, and that's the idea, to make decision. So in short, neural networks are used to calculate multiple point of input data, simulate a human ability to analyze and process that, and provide an output. The output could be used to make calculated based decision, and the reason this is important is a neural network cannot make human based decision. That's why you need this output here. It can help you to select, compare, analyze, and then basically really construct this data set that you have to decide upon. It will give you the data set that you need in order to make an informed decision versus having to come through all the different data here in the input it will go through. Now AI is great and all, but there are risks that are involved here, and one of them is misconfiguration or poor implementation. So if you misconfigure or you have an algorithm that's learned improperly, that's going to lead a high amount of errors. So we are talking about the supervised and all of the other methods where we are providing inputs. If we misconfigure or we provide poor inputs, we are going to get poor output as a result. We can also expect to get inconsistent data output because it's being produced by artificial intelligence, and the AI can be rapidly changing. If we are constantly introducing data input, then the output are going to be different every single day. because the AI algorithm has to calculate those and then form a data output decision. There's also an investment, time and money going to required for AI to learn its role or its function regardless of how we are doing this. So we need to implement this. We are going to need resources, infrastructure, all these different things. And the other part of the AI's decision are made and there's no regard for ethics, sensitivity, privacy or anything. This is calculation. So the calculation are made with no regards for anything else other than just the sheer output of the calculation. So that's where you want the human element to make decision based on ethics. Certainly from a privacy perspective, for regulation and compliance, and then there's also sensitivity. Some data outputs might have sensitive data, sensitive outcome, and we don't want those getting out into the wild. So the bottom line for AI is just to understand the purpose and the benefit of using AI based tool. Also understand the different type of machine learning we talked about here, supervised and unsupervised, and know the risk of artificial intelligence as well.